Okay, so we're looking at Pythagoras questions. We'll just get to it really. Find the length of the missing side for number one. So, you label them. A, B, C must be the hypotenuse. 3 marks. Formula. A squared plus B squared equals C squared. Substitute. That means that 6 squared plus 8 squared equals C squared. And then let's use our trusty calculator. So, I'm going to type in exactly as it is, 6 squared plus 8 squared, and you'll see that that's 100, so 100 equals C squared, therefore C is the square root of 100. Now, that's an answer as a surd, so that's what it's called, but because this has a whole answer, we know that C must be exactly 10 centimetres, and we'll talk a bit more about that as we go through it. So I'm going to do the next question in exactly the same way, and you'll see that. Alright, so you can see here that went through it in the same way. C is the square root of 170, which is the surd, or to 2 decimal places, it's 13.04 centimetres, and that's why I did the squiggly equal sign there. Now for number 3, you'll be careful because we're given the hypotenuse, so we're given C, and this time we're trying to find out what A is. So we use our formula again, A squared plus B squared equals C squared, or because it's plus B squared, you could go straight to A squared equals C squared minus the B squared. So all I did was move that. You could have substituted and then moved it. It doesn't really matter about the order. So now we go A squared equals 26 squared minus 10 squared. Once again, I'll put that into a calculator. 26 squared minus 10 squared. Exactly the same as it is. And therefore we get A squared equals 576. So to square root that answer, A is exactly 24 centimetres. So that's how you do it when you've been given the hypotenuse. Now be careful for number 4, because it's all about labelling it correctly, same as number 5. So we've got C, we're trying to work out A, because remember the hypotenuse is opposite the right angle. And then with number 5, we've also got C, and we're trying to work out what A is again. So once again, I'm going to quickly do that for you. Alright, so here's the answers to questions 4 and 5, and you can see I went straight to the formula of A squared equals C squared minus B squared, and I've answered to 2 decimal places for both of these questions. That's usually a good go-to, but you could answer in the surd form as well. Alright, next page. So look at the following diagram, find the length of the side marked X for part A, which is that one. So you know it's just a normal Pythagoras question. We've got A, B, C. So we go A squared plus B squared equals C squared, A is 7, B is 11, and C is our X. You could have left it at C. So you type that into your calculator, and we get X squared equals 170. So X is the square root of 170. Now you could answer that as a decimal, but I'm not going to in this situation, and you'll see why for part 2. Now find the length of the side marked Y. So we do this triangle, we've got C, A and B. A squared plus B squared equals C squared. Now we know A is 9. Now if I left B as a decimal place, it's going to be annoying and I might get a rounding error. So our length that we worked out was the square root of 170 equals C squared. So you can see what I'm done, I'm substituting in 170 for the one that we worked out at the previous answer to the question. You type that into a calculator, and you get 251. So therefore C must be the square root, or Y in this case, is the square root of 251. And now what you could do is you could now go back and answer both of them to 2 decimal places, because you won't have a rounding error if you only round once. So if you round more than once, you'll get something called a rounding error. And this one was 13.04 centimetres. So the question's there. Number 7 is an interesting question, and a lot of students don't read this and they get really confused. A bird flies 110 kilometres north, it then flies 80 kilometres east. How far away is the bird from the starting position? All you've got to do is draw your triangle. It's started here and it's gone 110 kilometres north and then 80 kilometres east. North and east are at right angles. So that's 110 and that's 80 kilometres. It's asking us to find this one, Pythagoras. A squared plus B squared equals C squared. 80 squared plus 110 squared equals C squared, and you type that into your calculator. So that's 18,500 is C squared. You square root that, and therefore C is roughly 136.01 kilometres. Now you will notice that sometimes I use the brackets and sometimes not. I mean, technically you should put brackets around when you substitute, but that's very important for negative numbers, but because we're only working with positives at the moment, it's not essential and you won't lose marks if you didn't put the brackets in. Right, let's have a look at number 8. This could be interesting. So bird flies 10 kilometres south, 15 kilometres east, 5 kilometres north, 10 kilometres west, 20 kilometres south, and finally 18 kilometres east. What is he doing? Alright, well what we need to do now is we need to work out the total distance. So roughly we think the triangle is going to look like this. So let's have a look. So he's gone, let's just look at our north and south first. So north and south are these. So where would he be from the start? So 10 south, 5 north, so that's 5 south, plus the 20, so he's gone south 25 in total. So again, you kind of want to work out the total distance where he finished, because then we're going to do the same with our easts and wests. So 15 east, but then 10 west, and then 18 east, so 15, take away the 10 is 5, plus the 18, so that's 23. So really, this distance that his little journey he's gone on, he's actually 23 east and 25 south. Let's use Pythagoras. And we got 25 squared plus 23 squared equals c squared. Which is 1154. And we square root that answer. So the bird is roughly 33.97 kilometres from his starting position. If it asks for the total distance travelled, then you'd have to add up all of his individual journeys. But if he wants to know how far he's from starting position, that's his journey, but really it was this triangle that I drew over like this. I just worked out the opposites. Last question. Love this question. So do examiners. They do it all the time. Now, you've got to realise that your cube kind of looks like this. Now, to find the diagonal here, this is the right angle triangle that you need. There. And you know the height of this triangle is 5 centimetres. And you know that this is the line that you need to find, the dotted one. But the problem is you don't have this line on the bottom. You know that it's 5 from there to there and 5 from there to there, but you don't know that one. But if you look directly above, down on the cube there, you'll see that this bottom triangle is this one here. So let's use Pythagoras here, with that being a, b and c. A squared plus b squared equals c squared. 5 squared plus 5 squared equals c squared. So c squared equals 50, c is the square root of 50. Once again, I'm not answering this in decimals because I'm going to use this answer. So now let's look at this triangle to finally find our diagonal. I said at the start that the height was 5, and this bottom bit is the square root of 50, whatever that is, and there's our c. We'll use Pythagoras here again. So you get 5 squared plus the square root of 50 squared equals c squared, which is 75. So this diagonal is the square root of 75 as a third, or we'll write it as approximately 8.66 centimetres. That's the last question there. Obviously, you go through this again. You must make sure you're marking yours in red pen.